So now I'm on an online graphing calculator called Desmos. If you're in my class, you've used this a number of times before, but if you're not, you may not have. This is the same graphing calculator that you'll be using to analyze the data you gather from your first rocket flight. But it's also really good just for graphing equations. So the parabola we've graphed so far was y equals x squared, which looked like that. Now, that parabola isn't going to be the flight of a rocket. The rocket was down here at time 0, 0. It wouldn't start out flying slow and then pick up speed on its way up. And if this were the graph of the rocket, it would never go down to 0 because this graph never turns around. So we need to be able to change this equation so we can start seeing parabolas that look like the paths of rockets, because that's what our goal is. So we need to be able to make some additions, some subtractions, and some rearrangements in this equation. First of all, rockets go up and then down. So the first graph I asked you to graph was y equals negative x squared. There it is. You could ask the sub to pause because that's the first graph you want to sketch. Y equals negative x squared. It goes down here at 0, 0. If you want to see some more points on this, some points you could graph are negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, and 2, negative 4. That's the first graph you want to graph. Y equals negative x squared is important because, just like on this graph, a rocket is going to go up and then down. Okay, so now we've got negative x squared. That was a good start. But rockets aren't going to be going below the ground. We don't want all of these values to be negative. So we have to be able to move this graph up. The next graph I asked you to look at was negative x squared plus 5. That's a little better. Here, we start at 0, something's at a height of 5, and then it goes down slowly. This is the same as my ball drop, where we've got at time 0, something's not moving, and then it slowly picks up speed before it's dropping pretty fast. So that's a more useful graph for us. This is the second graph I asked you to sketch, number 2, y equals negative x squared plus 5. Next up, I'd ask you to take a look at y equals x minus 3 squared plus 5. Now that was an interesting shift. Notice that now we've still got a graph that goes up, then down, but now we're even more useful for rockets because this graph starts down on the ground, then later is going to go up, just like our rockets will, reaches a high point up here, before it comes back down. So this is now a pretty useful rocket to us. This graph has a vertex, that's what this high point or maximum point is called, at 3, 5. And it points downwards, just like all negative x squared graphs do. Notice that I got this vertex at 3, 5 from my equation with this 3 and this 5. This is graph number 3, negative x minus 3 squared plus 5. The last graph I asked you to take a look at is in a very different form. Now you're looking at a graph that says x minus 3 times x plus 5. And you'll have to use a little bit of a different scale here. Here's a sketch of this graph. In this graph, now the 3 and the 5 are playing a very different role. Now the 5 and the 3 show you the x-intercepts of the graph. This equation is written in a different form that highlights the x-intercepts rather than the vertex, like the last form does. This is the last graph you need to sketch.